Good day. We're early in the game of Le Chatelier, so now is the time for a quick review to make sure things are under control before we move on. So you can see this is Equilibrium Qualitative Understanding. We're looking at equilibrium, which involves reversible reactions, and we want to understand that even though at equilibrium it may look like nothing's happening, it is dynamic. Every time the forward reaction happens, the reverse reaction happens, so the reactions occur at the same rate. It doesn't mean the concentrations of things are the same. It just means we reach a point where the rates of reaction, forward and reverse, are the same. So here are some conditions for equilibrium or to being able to recognize it. First of all, the system must be closed. Nothing can enter, nothing can leave. So if you have things like gases, you definitely need to have a sealed system. A lot of times for reactions that occur in solution, we typically don't have things entering and leaving, so it can have an equilibrium. Opposite reactions occur at the same rate. The equilibrium can be reached by starting with either all the products or all the reactants or some combination. The temperature is constant and the macroscopic properties do not change. Early on we talked about enthalpy and entropy. Enthalpy you should know about from before. You should know it's the heat of the reaction, looking at the difference in the energy of the products, subtracting the energy of the reactants. If the forward reaction is exothermic, then the reaction or equilibrium favors the products. If delta H is positive, endothermic, then the equilibrium favors reactants, all things being equal. Why is that? Well, things naturally tend to lower energy. Entropy, on the other hand, favors maximum chaos. So, when we talked about that, we said, hey, it's delta S is our symbol, the change in entropy. Gases have more entropy than liquids, have more entropy than solids. And let's see, we carry on. So we looked at the four possibilities in our notes. So we looked at whether a reaction goes to completion, or two combinations that give us equilibrium, or the one combination that gives us no reaction, which we commonly say is non-spontaneous. So these arrows represent the way in the equilibrium favors, all things being equal. So factors that can affect the equilibrium are temperature, if we have gases, pressure, and volume, concentrations, and catalyst. We have Le Chatelier's principle, something you should memorize. When an equilibrium system is exposed to a change, which we call stress, processes are going to occur to oppose that stress, and we reach a new state of equilibrium. So we have the concentration stresses. If you increase the concentration reactant, favors forward. Decrease concentration reactant favors reverse, etc. By now that should be no problem. So here's a little sample. Right, we have increase in the HI, goes to the right. Decrease the HI, comes to the left to replace the HI. Increase in the H2, it's going to go to the left, and decrease in H2 is going to pull it to the right. So that should be easy. Temperature, if we increase the temperature, it favors the endothermic direction, which is absorbing energy. If we cool an equilibrium system, it favors the exothermic direction, whichever way that is. When we look at this situation here with the HI and the energy, then we see the forward is endothermic, so increasing the temperature will shift it right, and decreasing temperature will shift it left. Pressure changes only affect equilibrium or equilibria involving gases. Increases in pressure favor the side with fewer moles of gaseous particles, and that's according to coefficients. And decreasing the pressure favors the side with more moles of gaseous particles because they can better fill the extra volume available. If the number of moles of gas are equal on both sides, then there's no shift when we have the pressure change. So we look at this system, and we've looked at that in the notes before. Increasing the pressure, it goes right. Decreasing pressure goes left. Catalyst, no effect on equilibrium position. So hopefully that's a useful recap and provides a tidy summary for what we've done so far with regards to Le Chatelier and a qualitative look at equilibrium.